Hello, parents, teachers, and any students who may be watching. Welcome to Creating Math Ahas for Parents. I'm Dr. Sandy Atkins, Sandy, and in this video, we'll be looking at the meaning of subtraction and some subtraction strategies. Now, I'd like to spend a little bit of time thinking of the meaning of subtraction because that helps us with the language of story problems. One way to think of subtraction is the way many of us learned about it, removal or takeaway. But another way to think of subtraction is comparison. When we start to see how many more, how many fewer, how much longer, how much farther, in those types of problems, we're using more of a comparison subtraction. Now, when many of us see this expression, numerical expression, we read it as 5 minus 3. Perfectly correct way to read that. The challenge is the word minus does not appear in story problems. They'd be much easier if it did, yeah? But we will hear words like take away or remove. We might read or hear how many fewer, how many more. So what we want to do is read these symbols using that type of language so that we're building the language of word problems when children are doing those computation problems. So I might read this as 5 remove 3, 5 take away 3. How many more than 3 is 5, or how many fewer than 5 is 3? Now notice how in that first one, I use 3 first. I'm not reading left to right and not having to when it comes to subtraction and reading these symbols. So I want them to develop that language and use that language as much as possible when they're working with the symbols. So again, we're developing the language of word problems when they're learning the computation. Now, I'd like us to look at 4 different subtraction strategies. One is using place value. The other is a round and adjust strategy, decomposing a place or a whole, and counting up. Now, I'm going to give you an overview of these strategies, but I will be making grade level specific videos where you can see how each of these strategies fit into the grade level that your child is in. Now, using place value with a problem like this is relatively simple. I'm not needing to regroup or borrow, as I heard it called all through my elementary years, right? But regroup, think of 68 in a different way because I have enough tens and I have enough ones. I can remove 2 tens from 6 tens, 3 ones from 8 ones, no problem, right? But if I have this type of a problem, 62 minus 29, I don't have enough ones to use that direct approach. So I want to think of it a little differently. Now, when you think of why would you want to learn round and adjust or decompose a place or a whole or counting up, I want you to think about when you go to buy something at a store, and I'm going to pick quite small numbers, but let's say I'm going to buy something at the store that's 28 cents. I have never said to a cashier, I'm sorry, I don't have enough pennies. Could I trade you a dime for 10 pennies so I can pay you? Haven't. I might have given 3 dimes or the equivalent of 30 cents and hope that they give me back the correct number of pennies, right? So that's what round and adjust is about. It's that I can remove more than I have and then adjust. Okay, so if I'm doing 62 minus 29, I might be able to remove 30 and give back 1. Now, I want to show you how this looks with some of the models your children might be seeing. These are base 10 materials. The rods are worth 10. The units, you can see ones. We have models for 100 and 1,000 also. But if I'm using this strategy, what I'm going to do is remove the 30, give 1 back. Okay, this is what that equation looks like. Remove 30 and adjust. 1 back, I have 33. Now, this strategy works for fractions when your child is having to subtract mixed numbers. When I looked at this problem in the past, I thought, oh my goodness, I've got to regroup. But you see, I can use the same strategy. Now, this model is a fraction kit model. You might have your children or see that your children have made a fraction kit out of construction paper or or a paper handout of some type. And in this case, I'm showing 5 wholes and that 1/4. If I use this strategy, you see I can remove 3 wholes and give back the quarter. So same idea, it's a round and adjust, and this strategy will work for decimal problems also. In this case, I can remove 3 and give 2/100ths back. When I do that, I'm going to end up with 2 21/100ths. Now, what this is doing by using that strategy with these problems is I'm turning what was a paper and pencil activity for me, and I had a set procedure for getting the answer, into mental problems. Much more efficient strategy, actually, because when I'm doing 500, remove that 197, I can remove 200, 300, give 3 back, 303, done. And more than likely, I will have that answer before somebody writes the problem down. So we want efficiency, we want flexibility, and we want a strategy that doesn't just work for whole numbers, but also works for fractions and decimals. Another strategy is decomposing a place or a whole. I'm going to stick with the same problem. I'm going to start with the same base 10 representation, but in this case, I want to think of 29, place value, 20 and 9. I can remove the 20, but then instead of trading that 10 for 10 individual ones, I'm just going to break it. So I can break it into 9 and 1 because I still need to remove 9. Cross out that 9, I have that 33 left. Still works for fractions, right? If I have my 5 1/4, I can remove 2 wholes, separate or decompose a whole into 4 1/4 pieces, cross out 3 of them. I'm left with that 2 2/4. Now, the last strategy I'd like us to look at is a counting up strategy. In this way, we're really thinking of a comparison idea. How many more? Or using think addition. How many more than 29 is 62? I can count up. And this model is a part total chart or a total part chart. And you may see your children using this or seeing pictures of this in their materials. In this case, the total I'm trying to get to is in that top part, 62. And I know I'm starting with 29, and I'm going to count up from 29 to 62 to see what's going to go in that blank. So I start at 29, and 1 is 30, 40, 50, 60, 61, 62. Now, if you think about it, what we just did is how you count back change, right? We start with what it cost, and then we count back the change using those currency denominations until we end up at what they gave us. Same idea here. I'm learning to count back. I'm counting up to get to that total, but it will kind of mimic what we do when we count back change. Now, some children will start out by counting back ones, and they'll count back 33 ones, one at a time, to get to 62. But part of what we'll do is we'll work with them until they can count with the tens and count back those models that are much more efficient. Now, another way we might count up is using what is called an open number line. You may see this too. It's not different from what we saw, but most of our number lines might have started at 0 and might have had all the hash marks there. This is just a segment of the number line, and it doesn't have all the hash marks. It's open in that way, and then we can make jumps that we want to make within the 29 to 62. In this particular case, I could make a jump of 1 to get to 30. I could go 30 to get to 60 and then do a jump of 2. I'm counting up. I'm doing those jumps. You could picture starting at one end with 2 3/4 and the other one 5 1/4. Count up a 1/4 to get to 3. 2 wholes get me to 5. Another 1/4 gets me to 5 1/4. See, the strategy will continue to work. And I apologize for this not being to scale, but I hope that gives you an idea of what this counting up strategy looks like using a number line model or using that base 10 concrete model. So these are some of those subtraction strategies that let us work with multi-digit subtraction, when I'm using a place value idea or same size unit, when I have enough of those units to remove. And then we get to round and adjust. We can do that decompose a place where I'm still using some place value, but I might be breaking up one of those places into those pieces that I need, and then a counting up strategy. I hope this gives you some ideas about meaning of subtraction and why we're looking at that, the strategies that we can use. If this video was helpful, I hope you will like it, subscribe. As a reminder, look for those other videos that are grade level specific so that you can see what your child might be learning in their specific grade. I hope to see you there.